Assalamualaikum and good day. Our project installation of motion sensor at corridor and toilet for UNIMAP lab and office building turns sustainability goal into action at UNIMAP. This work direct support National Energy Transition Roadmap or NETR and contribute to Sustainable Development Goal SDG for clean energy and responsible consumption. More than just an upgrade, it positions UNIMAP as a leading technical university in implementing practical green technology. We are targeting a clear problem which is unnecessary energy waste from light left on in empty corridor, toilet and stairwells. This is a direct project that will reduce cost and our carbon footprint. Our technical specification is critical. We are targeting specific zone in the FKTA building for maximum impact. A key mandate is the use of IP65 rated IR motion sensor is area like corridor and toilet. The IP65 rating is not negotiable. It guarantees complete protection against dust and water jets. They ensure longevity and reliable operation in our very campus environment, making the system durable and effective from day one. This specification enable our three core objectives. First, to achieve 30 to 40% reduction in lighting electricity consumption. Second, to enhance operational efficiency through full automation, minimizing the need of manual control. And third, to direct lower unit carbon footprint and utility expenses, supporting our institutional Green Campus initiative. Okay, finally, our project scope ensure a complete professional outcome. We are delivering a full turnkey system from the initial energy audit and design through to installation and commissioning and ending with final documentation. This end-to-end approach is how we guarantee quantifiable energy saving and provide lasting support for UNIMAP sustainability goal. Thank you.
Assalamualaikum and good day. My name is Muhammad Aiman bin Ismail. I will present about work breakdown structure WBS for this project. This presentation covers the project activities, schedule, resources, budget and responsibility structure. Okay, this slide shows the full list of project activities, starting from project initiation until final handover. The activity includes site survey, identification of existing electrical layout, planning and coordination, sensor selection, installation, testing and commissioning. These activities ensure the project is executed in a schematic and structured manner. Here is the project activities and schedule. Each activity is arranged based on logical sequence and dependency. The schedule helps ensure the project is completed on time while considering realistic working duration and coordination requirement. This slide represents the resources required for the project, including manpower, equipment and materials. Proper resource planning is important to avoid delay and cost overrun. These resources directly support the execution and installation phase of the project. For the next slide, this table shows the budget estimation for each activity. The total estimated project cost is RM26,950. Budget planning ensures the project remains financially feasible and controlled throughout its life cycle. This slide shows the project master schedule divided into initiation, planning, execution, validation and launch phases. The linear responsibility chart clearly defines roles and responsibility for each activity. This helps improve coordination, accountability and communication among the project team. So this is our linear responsibility chart.
Assalamualaikum, my name is Muhammad Zikri Hakim Muhammad Sabri. So I will explain about the project scheduling using the activity on node, network diagram and critical path method for our motion sensor installation project. So as you can see here, list of activity, which is the activity are labeled from A to 0 to make sure scheduling is easier. They include the planning, design, procedure, installation, testing, and handover. Basically, here is a figure show the sequence of activity from the start of the project until completion. Each box represent one activity and the arrow show the order of work. The project start from initiation and end with final inspection and handover. So basically here ES, EF, LS, LF. So what's meaning that? ES mean early time and activity can start. EF means early time activity can finish. LS mean latest time activity can start without delay any project. So LF means latest time and activity finish without delay project. So basically here is a network diagram. So based on table select of each activity, select show how much delay an activity can have without affecting the project. Most activity have a zero slack, meaning they must be done on the time. Only activity K has slack of 5 so days. Here figure critical path and minimum duration. It show the red circle for each box is zero slack, which is the critical path is longest sequence of activity with no slack. For this project, critical path is A, B, C, D, E, F, G, H, I, J, L, M, N, O, which is the minimum project duration is 34 days. Any delay in the critical path will be delay the whole project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Talib and I will explain about the Gantt chart. Okay, for this project, the list of activities is structured using a clear and systematic approach to ensure smooth project execution. The activities are divided into 5 main phases. First is initiation, planning, execution, validation, and lastly is handover. The project begins with initiation and approval, followed by a detailed site survey and identification of the existing lighting and electrical layout. These yearly activities are critical and important because they provide accurate technical information before any design or installation work begins. Next, during the planning phase, activities such as preparing the project scheduler, coordinating with UNIMAP facilities, selecting suitable motion sensor, designing sensor placement, and preparing wiring schematic are carried out. These tasks ensure the system is technically feasible and compliant with safety requirements. The execution phase includes procurement of materials, marking installation location, installing wiring and sensor, and connecting them to the lighting circuit. Finally, the project concludes with testing, commissioning, final inspection, documentation, and lastly is handover. Overall, the clear predecessor relationship between activities help reduce risk, avoid rework, and ensure the project progress in a logical sequence. Okay, for the Gantt chart, I'm generate it using the Microsoft project software by using the list of activity from the WBS. So for the Gantt chart, provide a visual representation of the project schedule and show how all activities are distributed over time. The total project duration is 34 days, starting from 1 January 2026 and ending on 17 February 2026. Each bar in the Gantt chart represents an activity, clearly indicating its start date, end date, duration, and responsible personnel. The chart also highlights task discrepancy and parallel activities. For example, some planning tasks such as project scheduling and electrical layout identification are carried out to optimize time without affecting accuracy. The transition from planning to execution is clearly shown, especially for procurement, installation, and connection works, ensuring material are available before installation begins. In addition, the Gantt chart helps identify critical activities that must be completed on time to avoid project delays, while also showing limited flexibility in non-critical tasks. Overall, the Gantt chart serves as an effective tool for monitoring progress, coordinating resources, and ensuring the project is completed within the planned time frame. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal Daruslan and I will discuss for our project. So, this project has positive impacts on both society and the environment, and it is well aligned with the Sustainable Development Goals. First from an environmental perspective, it supports SDG 7. It is affordable and clean energy by reducing unnecessary electricity consumption through automated lighting systems. And this reduction in energy usage helps lower carbon emissions and promotes more efficient use of electrical resources. In addition, the project aligns with SDG 12, responsible consumption and production, as lighting is only activated when occupancy is detected. And this eliminates energy wastage in low occupancy areas such as corridors and toilets and, and encourages responsible energy consumption within the university. And from a societal perspective, the project actually improves user safety and comfort by ensuring adequate lighting when spaces are occupied. And at the same time, it reduces operational and utility costs of UNIMAP. And these cost savings can be redirected towards academic development, research activities, or student facilities, which creating long-term benefits for the campus community. And the project also supports SDG 11, sustainable cities and communities, by promoting smart and sustainable infrastructure in public institutions. So for the conclusion of our project is, in conclusion, this project is practical, feasible and well organized. It successfully achieves its main objectives by reducing energy wastage, lowering operational costs and improving overall efficiency through automation. The use of proper project management tools such as the Work Breakdown Structure or WBS, Critical Path Method (CPM) and Gantt chart ensures effective planning, scheduling and resource utilization. Finally, this project demonstrates the real-world application of engineering and project management principles while enhancing the learning experience for engineering students. Overall, it not only addresses immediate energy efficiency issues but also provides a scalable and sustainable model that can be implemented across other buildings at UNIMAP, contributing to smarter and greener campus development. That's all from our group, Juanji Solutions. Thank you for watching us.